Hi and welcome to my channel. My name is Tobias and today we're going to look at the product rule. So if we've got two differentiable functions f of x and g of x, we can apply the following rule. So if we want to find the first order derivative of the product of these two functions, we have to do this over here. So first we take f prime of x times g of x plus f of x times g prime of x. So this we have to apply every time we want to find the first order derivative of a product of two functions. So let's have a look at some examples. So example 1, we've got f of x, that's x squared, and we've got g of x, that's 2 times x minus 3. Down here I've written the first order derivatives of each of these functions. So x squared, the first order derivative is 2 times x, and the first order derivative of 2 times x minus 3 is equal to 2. And we have to use this down in this expression, so we find the product of the first order derivative of this product. So that would be the first order derivative of x squared times 2 times x minus 3 in brackets. And we just do this. We find the first order derivative of f of x, then we multiply it by g of x, and plus f of x times g prime of x. So we do this. So we find the first order derivative, that's 2x of x squared. Then we multiply it by this function over here, where we have done nothing, just multiplying it. And then we say plus the first one, just as it is, times the first order derivative of the second one. And if we expand this one, so 2 times x times 2 times x, that yields us 4x squared. 2 times x multiplied by minus 3 yields us minus 6x, and plus 2 times x squared, that's down here. And all in all we get, if we reduce this expression a little bit, we get 6x squared minus 6x. So that's our first order derivative of these two functions multiplied, or the product of these two functions. Let's have a look at another example. So we've got f of x equals x raised to the power of 3 this time, and we've got g of x equals e raised to the power of x. The first order derivative up here is 3 times x squared, and the first order derivative down here is e raised to the power of x. So if we want to find the product, the first order derivative of the product of these functions, we just put it inside brackets here and a mark. So x raised to the power of 3 times e raised to the power of x, and we just say once again the first order derivative of this expression, the first one, the first function, so that's 3x squared times this one where we have done nothing but multiplying, and then plus, and then we just leave in this one without doing anything other than multiplying it by this one where we have found the first order derivative, and it's a bit special here, so that's the same function. We just put it in here. Maybe we could reduce this expression a little bit, but that would be our final expression if wanting to find the first order derivative of this product of these two functions. Our third example, we've got 1 divided by x. That one has got this first order derivative, and we've got the square root of x down here, and that's the first order derivative of this one up here. So if we want to find the first order derivative of these functions, of the product of these functions, then we just put in 1 divided by x and square root of x down here. And we say the first order derivative of this one, that's minus 1 divided by x squared times the square root of x. So not doing anything to this one because of our rule here. So first order derivative times just the function as it is. And we say plus this one without doing anything times the first order derivative of this one. So that's 1 divided by 2 times the square root of x. So if we want to, we could just leave it here. We have used the product rule to get this result. If we want to reduce this, I've just put in some lines down here. So we rewrite this expression like this. So minus 1 divided by x squared could be written as this. The square root of x can be written as x raised to the power of 0.5. Sorry. 1 divided by x could be written as this, and we can rewrite this as this expression down here. And if we apply our normal rules here for powers, we can rewrite this as this expression down here, and we can rewrite this as this expression down here. And we get this result, x minus x raised to the power of minus 1.5 plus 1 divided by 2 times x raised to the power of minus 1 minus 0.5. This can be rewritten as this expression, and in the end we can see that both of these are raised to the power of minus 1.5. So we can just look at that's minus 1 before this one, that's the coefficient here, and plus 1 divided by 2, and that yields this result in the end. So we can go through all these steps to get this result down here. That's a much less complicated expression than this one up here. Then we've got our last example, that's example 4. We've got the function f of x equals e to the power 3x, and we've got g of x equals this polynomial x squared minus 4x plus 2. This is the first order derivative of this one up here, and this is the first order derivative of this expression of function down here. If we once again want to find the first order derivative of this product of these two functions, we just put them inside brackets and put our mark here. So this one times this one. Remember brackets around this one because it's got 3 terms. And then we say this one, the first order derivative times this expression unaltered here. So we write this, the first one, and then we say plus, and then we just leave this as it is, times this, or the first order derivative of this function here. So that's 2x minus 4, we can see that here. And maybe we can do some reduction here. So this is our expression. If we just wanted to find the first order derivative of the product of these two functions, we can reduce this a bit, so we can multiply this into all terms in the first bracket, and we can do the same with this expression here into both terms here. Then we get all these terms, so 3 times e raised to the power of 3x times x squared, that would yield this result, and we do this for every term in here, we get these results, and then we multiply this into both terms here, and we get this. And if we want to reduce that a bit, we get these expressions down here, because we've got minus 12 times e raised to the power 3x, and we've got plus 2 times e raised to the power 3x, so that will yield us this result. And we've got times x here, so that will be this result down here, and we've got 6 times e raised to the power 3x and minus 4 times e raised to the power 3x. That would yield us plus 6 minus 4, that would yield plus 2 times e raised to the power 3x. So that would be our result down here if we wanted to reduce this expression even more. Well, thanks for watching. See you next time. Bye bye.